Hey guys, it's Tiffany. Today we're going to talk about dimensional analysis. Dimensional analysis, using the metric system. Some things to keep in mind. Dimensional analysis is a type of conversion. It's slightly more involved than working with rates or proportions alone, but the concepts are similar. Cross-canceling is used with dimensional analysis. Memorizing or writing down common conversions is helpful when solving these types of problems. Start with rates or relationships that you know and add more rates until you get to the units of measure that you're looking for. Here are some metric conversions. Whenever you have 100 centimeters, remember that that's equal to 1 meter. And I have that written in the fraction here, okay? The same thing is true in reverse, which is written over here. When you have 1 meter, that's the exact same thing as 100 centimeters. The reason I've written these conversions twice, but in reverse, is because depending on how you're given your problem, sometimes you may want to include your centimeters on top or bottom, or your meters on top or bottom, or whatever your units are. So the rest of this chart gives a few more common conversions. There are definitely way more conversions than this. When I learned the metric system in school, I learned King Henry died by drinking chocolate milk. So of course that works when you're trying to figure out how many meters are in a kilometer, but on this chart, I've listed the most common ones, okay? So for every 1,000 meters, that's equivalent to 1 kilometer, or you can also pronounce that as kilometer. For every 1,000 milligrams, that's equivalent to 1 gram. And for every 1,000 grams, that's equivalent to 1 kilogram. Here are some time conversions. There are 60 seconds in 1 minute. There are 60 minutes in 1 hour. There are 24 hours in 1 day, 365 days in 1 year, and 10 years in 1 decade. Let's take a look at example number 1. The question asks, how many centimeters are in 1 kilometer? Well, I don't know how many centimeters are in 1 kilometer, but I do know that there are 100 centimeters in 1 meter. So I'm going to start by writing that. 100 centimeters in 1 meter, okay? Now I'm going to multiply this by something else that I know that could get us close to figuring out how many centimeters there are in a kilometer. So something else that I know is that there are 1,000 meters in 1 kilometer, okay? Okay, I have decided to write this conversion, 1,000 meters is equivalent to 1 kilometer, with my meters at the top because I know I'm going to cross cancel. And when I cross cancel, I'm going to get rid of things that are in my denominator by using things that are in my numerator. So I know I need to get rid of meters over here because my problem doesn't ask for meters. My problem tells me to start with centimeters, and it's asking about how many kilometers or kilometers that is, okay? So really, meters isn't something I need to deliver as an answer at all. I'm just using meters to kind of help me get to the answer. So what that means is I know that I'm gonna have to cross cancel and get rid of those meters. Well, the only way I'm going to get rid of them when they're in the denominator is if I include a fraction somewhere where the meters are in the numerator. So that's why I made sure to use the fraction that included the meters on the top, because they're going to cancel out with the meters that are over here on the bottom, okay? Now, I'm going to go ahead and cancel my units, get rid of meters, and I'm going to say, of the units that I have left, does it make sense for what my question was? Well, let me look back at the question. The question was, how many centimeters are in 1 kilometer? And right now, I have only centimeters and kilometers. These are the only 2 units that I have left over. My meters were crossed off, okay? They canceled out. So I know that I am going to be correctly converting centimeters to kilometers because they're the only 2 units I have left. So now I'm just going to multiply straight across. 100 times 1,000 is 100,000. And 1 times 1 is 1, okay? All I did was multiply my numbers straight across. I had 100 right here, and I multiplied it with this 1,000, and I got this 100,000. Then I had a 1 right here, and I multiplied it with this 1 right here, and I got this 1, okay? So my final answer for example number 1 is 100,000 centimeters are in a kilometer. So you could also say that there are 100,000 centimeters per every kilometer. Let's take a look at example number 2. Example number 2. So the question asks, how many milligrams are in 1 kilogram? And my first thought is, well, I don't know how many milligrams are in 1 kilogram, but I do know that there are 1,000 milligrams in 1 gram. So let me start with that. I'm going to write that first. I'm going to write what I do know first, okay? So 1,000 milligrams is equivalent to 1 gram, okay? Now remember, like our last example, I know that I don't really need grams, so I need to eventually get rid of it someplace. I need to cancel it out. The only way I can cross cancel it is if later in my problem, I have grams up top in the numerator section, okay? So what I need to do is make sure that I end up with grams somewhere in the numerator. And what I'm going to do is go ahead and do that step now. So I'm going to start with some amount of grams up top in my numerator. And hopefully I know how many grams are in kilograms. And I do. I know that there are 1,000 grams in 1 kilogram. Okay. So now I'm going to start cross canceling to see what I have left. I'm going to get rid of this gram and I'm going to get rid of this gram. Okay. And now I'm going to see what units do I have? Well, I have milligrams and I have kilograms left. And the question asks, how many milligrams are in 1 kilogram? So this tells me that I'm on the right track. Right now, if I were to multiply straight across, I'm going to end up with an answer that has the units of milligrams per kilogram. So I'm on the right track. So now I multiply my numbers. This means 1,000 times 1,000. And this is 1 times 1. In the last example, I didn't write this step out. I did it in my head, but I want to write it this time to make sure you understand what's going on. So my answer ends up being 1 million over 1. Okay. So my answer for example number 2 is there are 1 million milligrams in every kilogram. Let's take a look at example number 3. Bridget is riding her bike at a rate of 85 meters per minute. What is this rate in kilometers per hour? Okay. So first thing I'm going to realize is this is a little different than the last 2 problems. The last 2 problems, they gave me just like an open-ended unit and I needed to convert it. This particular problem gives us a scenario. So I'm not going to start with something that I already know, like there are 100 centimeters in 1 meter. I'm going to start with what they have given me, okay? And what they've given me is that she's riding her bike at a rate of 85 meters per minute. So I'm going to start by writing that down as my first fraction. I have 85 meters. And this time I'm actually going to write meters out as the whole word because my other unit is minutes. If I were to abbreviate with M, it might get confusing. Am I talking about meters? Am I talking about minutes? Okay, so I'm going to write that whole word out this time. 85 meters per minute. And it doesn't tell me how many minutes, so that means it's per 1 minute, okay? 1 minute. Now, again, I don't need to end up with minutes, so I'm going to get rid of it at some point. I need to end up with kilometers per hour. So minutes is just what we're using right now, but I do need to take it off. So I need to make sure I include minutes in the numerator so they can cross cancel. So how about I go ahead and do that part right now? And I know I need to get to hours because that's in the problem. So maybe I could find a relationship, or maybe I know a relationship between minutes and hours. So I would say there are 60 minutes for every 1 hour. Okay, that's the conversion I'm going to use right here. Now I'm going to multiply that by whatever else I need to get myself closer to my answer, kilometers per hour. Okay. Well, if you remember, minutes and minutes are going to cross out. Okay. I'm left with meters per hour. So meaning if I stopped right here and multiplied my answer straight across, my answer would be in the units of meters per hour. I don't want meters per hour, I want kilometers per hour. So I need to make sure I include kilometers somewhere on this thing. I don't want to start with hours at the top of my next fraction because I don't want to cancel it out. It's something that I do need. So I'm going to consider what I was given. And over here, the first fraction that I wrote was 85 meters per 1 minute. So the meters is what needs to convert to kilometers. So do I know a relationship between meters and kilometers? I have to think about it. And I'm like, oh yeah, I know that for every 1 kilometer, that is the same thing as 1,000 meters. Now I can cancel meters out. I have a meters over here in the numerator and I have a meters over here in the denominator. So now I'm gonna multiply straight across and I'm gonna use just the numbers. I have an 85 in the numerator that gets multiplied by the 60 and I'm gonna multiply that by 1. Of course, whenever you multiply anything by 1, it just remains the other number, but I'm still gonna write it just to make sure that you understand that all I'm doing is multiplying all the numbers that are in the top on my numerator, okay? Now I'm gonna multiply all the numbers that are in my denominator. So I have 1 times 1 times 1,000, okay? Now, when I multiply all of these together, I get 5,100 in my numerator and I get 1,000 in the denominator, okay? And when I divide my 5,100 by 1,000, I get 5.1 kilometers per hour. And that's exactly what our question asked us to get. They wanted to know the rate in kilometers per hour. So I'm going to circle that. Now let's take a look at our final example number 4. It says Bridget is drinking orange juice at a rate of 15 grams per second. What is this rate in kilograms per minute? So basically, if she were to drink a full minute, how many grams would she have finished? Okay. So I'm going to start by writing down what they've given us. Okay. This is one of the examples where you don't start with what you already know. You start with what they gave you. Okay. So I'm going to write down 15 grams per 1 second. Okay. And I'm going to multiply that by something that I do know. I don't really need to know seconds, so I need to get rid of it. So let me make sure I put seconds up here on the top. I'm going to go ahead and fill that in and say, I need to go from seconds to what are my time units that they're asking about? They're asking about minutes, okay? Do I know how many seconds there are in a minute? I sure do. There's 60 seconds in 1 minute, okay? So by putting the seconds on top, that's going to make it to where we can cancel our seconds out. And then I want to include minutes because I need to bring my answer toward what they're asking for, okay? So cross out seconds, cross out seconds. Right now, if I were to go ahead and multiply straight across, I would end up with an answer that was written in grams per minute. But I don't want grams per minute. I want kilograms per minute. So now I need to add this kilogram concept. Well, if I have grams on top over here in the first fraction, I know that my fraction that's going to cancel that out is going to have grams in the denominator. And I want kilograms, so hopefully I know a relationship between kilograms and grams, and I do. And that is for every 1 kilogram, that is 1,000 grams. Okay. Now I know I can cross out grams here, and I can cross out grams here, and I can multiply straight across, okay? Now, the numerator is going to look like 15 times 60 times 1, and the denominator is going to look like 1 times 1 times 1,000. Now, when I multiply all of these together, I get 900 on top, and I get 1,000 on the bottom. When I divide that, I get 0.9. And remember, our units are kilograms per minute. And I knew that I was solving for that because that's what I had left over here. I have kilograms here and I have minutes here. That should always happen. Whatever you're asked about in your problem should be what's left over in your work area before you start multiplying. Now let's take a recap. Dimensional analysis is a type of conversion. It's slightly more involved than working with rates or proportions alone, but the concepts are similar. Cross-canceling is used with dimensional analysis. Memorizing or writing down common conversions is helpful when solving these types of problems. Start with rates or relationships that you know and add more rates until you get to the units of measure that you're looking for. Now you try. Comment with the correct answer below, then head over to my website and click on video answers to see if your answer is correct. Bridget uses 25 grams of wax every minute to wax her car. What is this rate in kilograms per hour? SuperEasyMath.com. Don't forget to like and subscribe. Did you find this video helpful? You can support this channel by donating to Super Easy Math through PayPal. There's a link to it in the description section below this video and on the Super Easy Math YouTube cover photo.